Hey guys, Mr. Bowman here. In this video, we're going through the 2021-9 Extension Algebra Skills Test. Hopefully this gives you a good idea of what your test is going to look like. Keep an eye out for the 2020 test, which I'll also upload as well. So this question starts off by saying use your substitution skills. So it's even telling you what to do for the following question. The volume of a cylinder, so that's our cylinder there. It's even give you a bit of information. That is known as the height, that there is known as the radius. We've been given this formula here. We should ignore units for this question. And then question number one, which I'll just jot up here. Question number one, if the cylinder has a radius of 7, so what that means is r is equal to 7 and a height of 10. So that tells us that h is equal to 10. Our job is to find the cylinder's volume. So what we're going to do is we're going to jot down our volume formula, which we had above, underlined it before, but the volume is equal to pi r squared h. We now substitute, because there's no operations, all of this is multiplying together. So we know that pi times 7 squared, so the r goes away and the 7 comes in, that's my substitution, times 10, again the h goes away and the 10 comes in. That should be the volume of the sphere. We now start simplifying. Bit of BEDMAS here. Pi times 49, I'm doing the squared first, times 10. I'm going to do the 10 times 49, so that's going to be 490 times pi. And after that, I've got 1,539.4. I've been told to ignore units, so I will. And I've rounded that to 1 dp. Just a note, if you rounded to 2 dp or 0 dp or 3 dp, whatever it might be, as long as you state your rounding, whatever answer you did was perfectly acceptable. We are now moving on to question number 2. If a given cylinder has a radius that is half its height, so we know the radius is going to be half whatever the height is, calculate the cylinder's volume if it has a height of 30 centimeters. Of 30 units. So we've been told that h is equal to 30, and what made this a merit question was there's a bit of reading of the words to get the maths out of it, but we've been told the radius is going to be half of that. So from this, I know that the radius is going to be equal to 15. Like I did above, I'm going to jot down my formula, substitute, and calculate the answer. So v is going to be equal to pi r squared times height. I'm going to substitute in the r and the h now, so pi times r squared, which will be 15 squared now, times h, which is now going to be times 30. Like I did before, I'm going to use my BEDMAS skills just to calculate this. So pi times 15 squared, that's 225 times 30. 225 times 30 is 6,750, and we times that by pi. And this is where we'll need our calculators, and that answer is going to get us to 21,205.8. And again, that had a 1 dp rounding. Don't forget, your rounding can be different, and that's all good. To question number 3, and I should note that E there, that means it is the first excellence question, because that was merit and that was achieved. Let's get into it. If a cylinder's height is 5a, so h is equal to 5a. Just a reminder, we don't know the exact value this time, but we do know how to deal with algebra. 5a is just an algebraic expression. We know how to add, subtract, powers, whatever. So that's all good. And the radius is 1/3 of the height. So the radius will be 1/3 times 5a. Don't forget, that's a fraction. So I'm just going to simplify this a little bit. That's over 1. So top times top is 5a, bottom times bottom is 3. So we now know the height in terms of a, and we know the radius in terms of a. We've been asked to form an expression for the cylinder's volume. Your answer must be left in terms of a and must be in fraction form. So same thing, we're going to get into our formula. So v will be equal to pi r squared times height. We're going to substitute in the height. This time around, we're substituting in 5a, and I'm going to use a bit of brackets to help me with my simplifying. I'm then going to substitute in my r as well. So let's get into those. So that means that will be equal to pi times, and this is where it's going to get very messy, 5a over 3 squared times 5a. So just noting the expressions I've substituted in, I put them both in a bracket just to make sure I'm not doing any silly math errors. I'm now going to start to simplify, and it looks like that middle part's going to be really messy. I've got a power with an unknown, so I need to use my indice rules to help me simplify that part. So we're going to have pi times, and our indice rules, so 5a squared divided by 3 squared. So that squared impacts the top and the bottom of that fraction. And that then is going to be multiplied by 5a. I'm going to lose my brackets this time because there's no other tricks or maths associated with that 5a. So continue on to the next step. We've got pi times, we're now going to expand the top bracket. 5a squared will be 5 squared and a squared. 5 squared is 25 and a squared stays as a squared. That's going to be over 3 squared, which I'm changing until 9. And that's going to be times 5a. Now this looks a bit messy, like, how am I going to simplify this? But the big giveaway is the fraction answer, and we've been asked to leave our answer in a fraction form. So I'm going to go over 1, and I'm going to use my top times top, bottom times bottom approach just to do this. So that's going to be pi times 25a squared times 5a, and that's going to be over by 1 times 9 times 1, which will be 9. I'm now going to finish up simplifying the top there. I'm going to start off with the numbers, which is 5 times 25. That there is 125. I'm going to leave it as pi this time, because if I change it to pi, I'll get a messy decimal, and that will defeat this fraction purpose that we've been told about. And after that, a cubed times a squared. A squared times a cubed gets to a cubed. And then I'm going to divide that by 9. I'll leave it in the fraction form. So that one there, really, really messy. Some intense algebra and substitution involved in simplifying that. But hopefully you got it. On to question number 4. And I should note, from the previous instructions, we're still simplifying over here. I've got 2a squared minus 9a plus a squared. This looks like a grouping like term questions because of all the addition and subtraction. So I know that the a squareds I can put together. So 2a squared plus 18a squared. That there is going to get me to 20a squared. And after that, I've got minus 9a. I've got a squareds, but I've got no other a's. So what I'm going to do is I have to leave that separately. So I'm going to go minus 9a. 5. It looked like I had a similar theme to that first question. I can only see addition and subtraction signs. So I'm going to go ahead and simplify that. And I'm going to start with the x's because I like to deal with things alphabetically. I've got 7x minus 6x gets me to 1x. And then I'm going to deal with the y's. I've got 10y's over here, 11y's over here. So that's going to be minus y. Just a note, 1x minus 1y, it is the same answer, but it is poor form in our algebra to leave those ones there. We try to get rid of those ones. We are now on question number 6, and just observing, I've seen some multiplication signs now. I wouldn't worry about these kind of minus signs because they're just negative references. So when we're multiplying all these expressions, we're going to start by multiplying all the numbers out front. So negative 6 times negative 3, that gets me to positive 18. I'm then going to do 18 times negative 2, that gets me to negative 36. So the first part of my answer on the right is going to be that negative 36. I'm now going to deal with all the letters, and again, I'm going to deal with them alphabetically. I can see one C over here and another C here. C times C is going to get me to C squared, and I've got a lonely D here, no other letters like that, so I'm just going to put that there, no other simplifying needed for that. Now on to question number 7, and this one is a bit trickier, but like multiplication, division has the same effect. So we're going to start off with the numbers, and we're starting off with the 15 over 25. 15 over 25. This can't divide 15 easily, so we need to treat it as a fraction. They've both got 5's in common, so 3 times 5, 5 times 5. I'm going to cancel out the common factors, which gives us to 3 over 5. So that's going to form part of our answer, 3 over 5. I now look at the letters. We've got to think who's got more x's, the top or the bottom. And in our case, it's x cubed over x cubed. So we're going to ignore the x's. We then look at the y's. There are 4 y's on the top, 3 y's down the bottom. So we've got y4 over y cubed. We have more y's on the top. We've got 1 extra y. So I'm going to put 1 y on the top there. Now on question number 8. This one here does look a bit tricky because it does appear that I've got a minus sign and a times sign. And a friendly reminder, our BidMath skills still work when we're multiplying. So I'm going to start off with by simplifying that there. So I'm going to have 3a cubed, which I'm not changing yet, minus, and now I'm just going to simplify that. That's also going to be 3, oh no, sorry, that will be 2a cubed. Now that we're just left with subtraction, we can group the like terms, and because both of these are a cubed, I'm going to go 3 minus the 2 gets me to 1. So I've got 1a cubed, but just a reminder, I don't want that 1 out front, so that's going to be a cubed for our final answer. Question number 9, our final question here. We've got a division, but I've got some multiplying on the top and some division or some subtraction down the bottom, so I'm going to start by simplifying all that. 10b times 4 is going to be 40b, and that is over 12b minus 4b, so that's going to get me to 8b. Now that I've got a fraction or division left over, I'm going to start by dividing the numbers. 40 divided by 8, well that's 5, that's nice and easy. B divided by b, those b's cancel each other out. Technically, it's over 1 because there's nothing down the bottom, but we're going to leave that as a whole number, so 5 would be the answer for question number 9. On to question number 10, and because it's a fraction, I'm just going to write it out fully, but we had 2a over g times 3 over 2h. I suppose the first thing to note is we're multiplying 2 algebraic fractions, so I'm going to use my top times top, bottom times bottom approach. So top times top, that's going to become 6a, and bottom times bottom, 2gh. Just noting I put that in alphabetical order. I now need to think, well, can I simplify this in any way? And yes, I can. That 6 divided by 2, that comes to 3. So that means we're going to have 3a divided by gh. Just a reminder, technically we had that invisible 1 down the bottom, but I'm going to ignore that. On to question number 11, and that was negative 3x cubed y times 2xy. We've only got one operation here, which is the multiplication. So I'm going to go number times number. Negative 3 times 2 is going to be negative 6. I then have a look, how many x's do I have? I've got 3 here and 1 here. So it's going to be x to the power 4, and I've got 2 y's, which makes y squared. Question number 12, doing it at the top of the page. We've got b divided by 2a plus a divided by 2b. So we've got two fractions. This time around we're adding, so we're going to be using the crisscross smiley face method. So I'm going to start off with by bottom times bottom, and that's going to form the numerator of our fractions. So we're going to have 4ab, and then we've got 4ab over here as well. We then do our cross part of it. b times 2b is 2b squared. We're then doing the same the other way. 2a times a, 2a squared. We simplify that because we've got the same denominator now. We're just going to add together the top, and that's going to get us to 2a squared plus 2b squared. Just noting, I'm only doing that alphabetically. If you had them the other way, that's all good. Divided by 4ab. What I can see here is there's a whole lot of 2's everywhere. 2, 2, and that 4 is 2 times 2. So I'm going to look to cancel out a common factor. So I'm going to divide everything by 2. So 2a divided by 2 is just going to be a squared. 2b squared divided by 2 is just going to be b squared again. And then down the bottom, we're going to be left with 2ab. I just want to note at this stage here, because the top is addition, we can't just cancel out the a's and then cancel out the b's. That's mathematically incorrect. So we've got to leave it as, just as an example, 3 plus 7 over 5. So that's going to be 10 over 5, which is 2. But imagine if you just started cancelling stuff out. You'd just be left with 7. How does that work? Makes no sense. On to question number 13. And I've got 4t cubed, and all of that is going to be squared. So just a reminder, I'm going to expand my brackets. That squared must hit the 4, and it also must hit the t cubed. So that's going to become 4 squared times t cubed times 2. Just a reminder, the powers multiply each other when you're expanding the brackets, and we can simplify that to 16t to the power of 6. Right, question number 14, fairly annoying, but we had negative 4x to the power of negative 2. The key issue here is that power of negative 2. And what we're going to do is we're going to move it to the denominator to make it a positive power. So I'm going to go over 1, and then the negative power is going to move to the bottom as x squared. So that's going to be negative 4 over x squared. Just a reminder, that 1 that was sitting at the bottom is now invisible, so we no longer need that. On to question number 15, and I should note this is the second excellence question of the exam. And our question was, it was a bit messy, but up the top we had 2x cubed y, and all of that is to the power of 3, and that was over 3xy, close bracket, to the power of negative 2. The first issue I see is the negative power. Whenever you see a negative power, you should look to make it positive. And what I'm going to do is I'm going to move this whole thing to the numerator, and it will end up being multiplication there as well. So that's going to look like 2x cubed y, all of that is cubed, times 3xy, close bracket, squared. So hopefully you can see what I've done here. We've now got that as a positive 2 instead of a negative 2. I've now got my bracket rules to apply. So 2 cubed is going to be 8. X to the power of 3 cubed is x to the power of 9. And y cubed becomes y cubed. Makes sense. Times, oh gosh, I've written another 8. But 3 squared is going to be 9. And then we're going to have x squared and y squared. We then are left with just a multiplication scenario. So we're going to deal with the numbers first. 8 times 9 is 72. Then the x's, x to the power of 11, and then the y's, y to the power of 5. If you managed to get all the way there, that was excellence. Just a note, if you don't think you can complete the questions fully, do some of the earlier steps, because in the earlier steps, if you moved it to make a positive power, I think straight away I gave you a merit mark. If you showed me some other indice rules, maybe down there, I also gave you achieve marks. So make sure you're showing all your skills, because you might be able to get part marks even if you don't get the whole excellence mark. Number 16, this is actually the third excellence question from this, and the question, it looks a bit nasty, but we're looking for the cube root of 8g to the power of 27, h to the power of 6. So the first thing to note is we're just going to break it up into its parts, and forgive me, I probably should have had more room, but that's going to become the cube root of 8 times the cube root of g to the power of 27 times the cube root of h to the power of 6. When we simplify all of that, the cube root of 8 is going to be 2. I'm just going to change how these two look because they are a bit messy. Remembering a surd is also a fractional power, so they may be a bit easier to deal with. So what I'm doing is I've got g to the power of 27. A cube root has the power of 1/3. And I'm going to do the same for the h to the power of 6, 1/3. I'm now going to simplify all of this. The brackets, I can just use my multiplication rule to expand them. So I'm going to get 2g to the power of 9, because that's 27 times 1/3. And then we've got h to the power of 2, which is 6 times 1/3. Question number 17, I've got it over there, but the question was negative 10, and then the brackets 9c minus 4. When I expand that, I like to use my rainbow method, so I'm doing that one times that one, and that's going to be negative 90c, and then I'm going to do this times this, and that's going to get me to plus 40. Because I'm a bit OCD, I'm just going to put the negative thing at the end, so it'll be 40 minus 90c, but either of those two would have got you all those marks. On to question number 18, and I've got 2ab, and in brackets, a minus 2b squared. Again, I'm using my rainbow method. 2ab times a is going to be 2a squared b. And then we're going to subtract 2ab minus 2b squared. So 2 times negative 2 is negative 4. And that's where that's coming from there. Then we've got 1a and we've got 3 b's across that. Final one here, question number 19. We've got in the first bracket x plus 9 and we've got x minus 3. I'm going to start by doing x times x which is x squared. I'm then going to do x times negative 3, which is negative 3x. I've then got 9 times x, which is plus 9x. And then finally, 9 times negative 3, that's going to be negative 27. I now group the ones in the middle. Negative 3x plus 9x, that's going to be 6x. So hopefully you're getting x squared plus 6x minus 27. We are now on to question number 20. The expanding is getting a bit more intense, but we've got 3x minus 2 squared. Your very first tip for this question, because it's a perfect square, write it out as a double bracket, and from there we can expand. So 3x times 3x, 9x squared, 3 times negative 2, negative 6x, and then we've got the same thing again, another negative 6x, and then we've got plus 4. And we group the terms in the middle, and that's going to get me to 9x squared minus 12x plus 4. I should note at this question here, I see this wrong all the time, but a lot of people tell me 9x squared plus 4, and that's because they do 3x squared and negative 2 squared. That is definitely 100% wrong, and that issue happens when people do not write it out as a double bracket. Do not make that mistake. Every time it happens, a little bit of me dies on the inside. To question number 21, and just note, we've got a whole lot of single brackets happening here, so I'm going to need to expand each of them and then group all the terms together. So our expression was 5 bracket 2a plus 1. We then had plus 3a plus 9, and then after that we had minus 2, 7a plus 1. So let's get into that. Let's use our rainbow method. 2a times 5 is 10a. That times that, we get to 5. Then over here we have 3a. Over here we have 27. This one here's got a negative, so make sure we're paying attention here. Negative 2 times 7a, negative 14a. And then negative 2 times 1 is negative 2. We now group the terms together. We'll do the a's. 10a plus 3a is 13a, minus 14a gets us to negative 1a. We've then got 5 plus 27 is 32, minus 2 brings us back to 30. Again, I don't like having negative things at the beginning, so what I'm going to do is I'm going to go 30 minus a. But just a reminder, whatever you had in the test, I would have given you full merit marks for that. Question number 22, just jotting down the question, but we had 3 and then brackets x plus 1, 4x minus 1. So my first step for this is I've actually got 3 parts. I've got the 3 there and I've got the 2 brackets. I'm going to start just by focusing on the first 2 parts there. And I'm going to expand this, and it's a single bracket. So getting into this one, that times that, 12x squared. Then we've got over here negative 3x. This times this is plus 12x. And then finally down the end, minus 3. I'm now going to group these together here. That becomes plus 9x. So our final answer, 12x squared plus 9x minus 3. So that there was a merit mark. An excellence expanding question over here, question 23. And this one here was a doozy. I'm going to start, because these are both perfect squares, I'm going to start by doing them as separate. I'm going to open up the double brackets for both of them. So I'm going to have 3, 2x plus 1, and then we've got 2x plus 1 here. And from that, we're going to minus x plus 2, and then x plus 2 over there as well. So this minus sign at the beginning is going to be really, really irritating, and I'll show you why in a little bit. So first step, just like we did for the previous question, let's expand that over there. So that there is going to become 6x plus 3, and then in the next one, we're going to have 2x plus 1. After that, I'm going to go minus, and I'm going to put a bit of a square bracket here, and now I'm going to expand all this stuff here. That's going to be x squared plus 2x plus 2x. I'm going to group these together now to save me a line of working, but they become plus 4x. And then finally, it would end up with 2 times 2, which is 4. So I've got that square bracket there. I'm now going to expand this nonsense over here. That there is going to get me to 12x squared, which was the 6x times the 2x. I've then got plus 6x plus another 6x and then we've got plus 3. This part here is annoying because we've got an invisible 1 here. So we're going to go negative 1 times x squared is negative x squared, negative 1 times 4x, negative 4x, and negative 1 times 4, negative 4. So that negative 1 actually made all of these bits, turn them all negative instead of positive. And a very common mistake is people will leave these last ones here as positive, but they are impacted by that negative 1. Now that I've done all that, I'm going to group all my terms together, so it's getting messy. But there are my x squareds, and that's going to become 11x. Here are my x's. I've got 12 over here, minus 4 over here. So it's going to get me to plus 8x. And then finally, here are my numbers, 3 minus 4. That's getting me to negative 1. Looking at question number 24, just to note, I'm now shifted over to the factorizing section, and that was a really, really important part of what we did in our topic. I think we had 5 factorizing learning objectives, a 6th one if you include the other one. But we've got 8st plus 12s. So your first step is to look at your common factors, and just a reminder, that 8 is actually 4 times 2, and that 12 is 4 times 3. So if you look what they have in common, I can see 4s and I can see s's in common. So I'm going to take out 4s. I now need to think what's left over. Well, I've taken out that 4, I've taken out that s, so I had 2t left over. 2t. The next one, I've taken out that 4, taken out the s. The only thing I've got left over is a 3, so I'm going to write plus 3. And that there would be my single brackets for that. I should note this isn't a quadratic because there's no numbers, there's no 3 parts to it. It's not a difference between 2 squares, definitely single bracket. Now on to question number 25, and this one here has got 3 parts. It's got v squared, 18v, and 80, so definitely going to be a quadratic. So I've now got to think, well, what's going to plus to 18, what's going to times to 80? And running through all my factors, I'm going to get 8 and 10. So those are going to be my 2 numbers in the brackets. They're going to be positive, and we'll have a plus sign there because of that. So we've got x plus 8, x plus 10. Question number 26, and straight away I know this is going to be a quadratic, again because of the 3 parts, and I also know it's going to be a bit more annoying because of that negative 99. So I now need to think what adds to 2 and multiplies to negative 99. Because it's negative, it's probably going to be 1 positive, 1 negative. So if I list all the factors of 99, I would have got 11 and 9 on that list. And I like that because they have a difference of this 2. So I've now got to think which one's positive, which one's negative. And that's when I look at the 2a. I've got plus 2a, which means the bigger of them is going to be positive. The smaller one will be negative. So plus 11 and minus 9, they will add together to get 2. They will multiply together to get that negative 99. So there are 2 brackets. We've got a plus 11, and we've got a minus 9. I also just realized I made a bit of a boo-boo in that second question. That one there should be v and v. Just noting, if you did that in a test like I did here, I'd probably give you the marks because you've shown me the skill. You just made a little error, kind of just out of habit for using x all the time. To question number 27, and we had 4x squared plus 10x minus 15. This one here, the 4 there meant we're using the grouping method. So 4 times negative 15 is negative 60. I now need to think what multiplies to negative 60 and adds to positive 10. And in this instance, we would have ran through all our factors. We would have gone 1 and 60, 2 and 20, 2 and 30, 3 and 20, 4 and 15. We've got 5 and 12, 6 and 10, 7, 8, 9 wouldn't have made a difference here. So I now need to think which of these have a difference of 10. And in this case, it was interesting, none of them had a difference of 10, which means this one here, it can't be factorized. And if you told me that, that's how you would have got your merit mark. I should note this question was genuinely just an error, but the way it worked out was we could award marks and we didn't have to disregard that question. On to question number 28, and if you have a look at this question, there's 2 parts. We've got a plus sign, so it's probably going to be a single bracket. So just jotting down the question, we had 12x cubed y squared z plus 9xy cubed z to the power 4. Your first step is to look at your common factors, and 12 and 9, they were similar to our last factorizing, so 3 is going to be the common factor. So I'm going to take out the 3. I'm now going to look at the x's. The greatest amount of x's they have in common is just the 1. The y's, they've got 2 y's in common, and the z's, they've just got 1 z in common. So I'm taking out all 4 parts of that. What's left over? Well, the 4 is left over from the 3 times 4. X squared is left over because there are 3 x's and I only took out 1 of the x's. We've got y squared, so there's none of those left over, and z, none of those left over either. That's the first part. I'm now going to do plus. I'm now going to look at the next part. I had the 3 left over because 3 times 3 gets me to that 9. I've already taken out of an x, so there's no x's to put there. I've taken out 2 y's, but there's 3 up here, so I've got 1 y left over. And z, I've taken out 1 z, and there's 4 up there, so that's going to be z to the power of 4. Question number 29, another excellence question following on that one from factorizing. I see a whole bunch of squares everywhere, a squared, x squared, b squared, y squared. And the thing I'm liking is that minus sign in the middle. So what I'm going to do is I'm going to use the square root approach. So a squared, x squared minus b squared, y squared. I'm going to use the square root approach to figure out the difference between two squares. So the square root of ax squared is going to be ax. And that makes sense because ax times ax is a squared x squared. The square root of b squared y squared is going to be by. So I'm going to go plus by and minus by. And again, that makes sense because that would become b squared y squared. So one of the easier excellence questions, I think, but that's assuming you can see it's a difference between two squares and assuming you adopt the square root approach. Question number 30, and it is an excellence question, and gee, is it a doozy of a question. We've got 9y squared minus 24xy plus 16x. What made this question really tricky was there is a common factor of x here, and if you didn't spot that, it was going to be an absolute shambles of a go factorizing this. So what I'm going to do is I'm going to take out that x, so x, and then that leaves us with 9y squared minus 24y plus 16. And now with the y's, we've just got a regular quadratic with a 9 in front means we've got to use the grouping method. So we're going to start by doing 9 times 16, which is equal to 144. And I'm liking 144 because straight away I'm thinking 12 times 12, and that gets us to that 24 sitting in the middle. So the factors I care about, negative 12, they add to negative 24, and they multiply to 144. So let's split this up into the two 12s. So we're going to have x 9y squared minus 12y. I need to stop writing x by mistake. Minus 12y plus 16. Close bracket. I now factorize the groups. There's my first group. There's my second group. So x, and this is where it's going to be a bit messy. They've got a 3y in common, and I'm going to use a square bracket with a 3y minus 4. Same thing here. They've got a negative 4 in common, leaving us with 3y minus 4, close bracket. Just to note, if you're minus 4 plus 4, maybe they're different. That might mean there's some kind of negative times a negative issue, so just double check by expanding that. I can see the same bracket coming up twice, so x will be 3y minus 4, and that's the bracket which I can see. The leftover bits, which are also 3y minus 4, sit there. And once I've done that, I know it's a perfect square now, so my final answer, x, would be 3y minus 4 squared. And I know it's going to be a bit ruthless, but if you missed that last part, you are not getting excellence for this question. To question number 31, and this is the last of the excellence questions from our exam. I'm going to start just by jotting down the question, 3x minus 3, and then we've got 5x squared minus 3x minus 2. And This time around, it looks really messy, but what I can see, the plan I'm going to use is I can factorize the top. The bottom is a quadratic, so I'm hoping I can factorize that. And once I've done those, hopefully there's some stuff that's going to be cancelling each other out. So let's start off with the denominator, and just to the side of that, I'm going to do my factorizing. So I'm going to start by 5 times minus 2 is negative 10. I now need to think what multiplies to that negative 10 and adds to negative 3. And that there should be, what's that, negative 5 and 2. So they add to negative 3 times the negative 10, which means when I do my split, so 5x squared minus 5x plus 2x minus 2, I can factorize the first group and the second group. So the first group have a 5x in common, leaving x minus 1. The second group have a 2 in common, so I've got plus 2, leaving us with x minus 1. And I'm liking this, the same brackets come up twice. So that's going to be my first bracket, x minus 1, 5x plus 2. And that second bracket comes from the leftovers, 5x plus 2. That's going to be the bottom. We could also factorize the top. They've got a 3 in common. This will be a regular single bracket factorizing, which comes to 3, and then a bracket's x minus 1. I'm now going to change how my question looks. I'm going to go 3x minus 1 over my double bracket, which is x minus 1, 5x plus 2. And I really like what I see because I can see a common bracket, which I'm going to cancel out, leaving my answer as 3 over 5x plus 2. Question number 32. An unknown number is tripled. So that there, for example, would be 3x. And then 2 is taken away. So that there would be 3x minus 2. Question 33. 4 is added to an unknown number. So that there would have been x plus 4, which is then divided into portions of 3, which is divided by 3. Remember, we've got those invisible brackets there, but as long as your fraction or your division sign covers both the x and the 4, you would be all good and you would get marks for that. We are now on to question number 34, and this one wasn't done too well, but we had an unknown number is squared. I'm going to use x squared for that, and then divided by, and a keyword, another unknown number. So that is not the same unknown number, so we're going to need another letter. So let's say divided by y. So when you look like that as a fraction, x squared over y, that would have been your answer for merit. If you had the x down the bottom as well, you would have been wrong because that's the same unknown number, not another unknown number. And the very final question, question number 35, 1/2 of an unknown number, so 1/2 of x, is subtracted from 4/3. So that's going to be the same as 4/3 minus 1/2 of x. So let's put this over here because we need to do our simplifying because it tells us to fully simplify. So 4/3 minus x over 2, noting I've changed 1/2 of x to x over 2. It is subtraction, so I'm going to use my crisscross smiley face method. So 2 times 3 is 6. I'm then going to go down this way. That's 8 times this one minus 3x. And that there would be my final answer worth a merit mark. Doesn't look like there's any common factors, so we would leave it as it is. So that was a summary of all the questions in the Year 9 Algebra skills test from 2021. Keep an eye out for the 2022 video, which also will be of use. Thanks so much for watching, guys. Keep working hard, and best of luck for your test.